Hello, our distinguished guests and channel partners. Welcome to our event today. I am Stone, Product Marketing Manager for DMR trunking system in Hytera.
I'm Gloria, also Product Marketing Manager for DMR trunking system in Hytera.
Today, we are honored to introduce Hytera brand new DMR trunking cube base station DS-6250S based on SDR technology and multi-carrier technology. The next generation of cube base station with a smaller form factor and hair integration, which is cost-effective yet powerful in networking. Hi, Gloria.
Yes.
Do you still remember when the first generation cube base station DS-6250 was released?
Yes, it was officially released in 2016. Emerged as a pretty new base station in DMR field. It has been deployed in many countries with over 8 years marketing. Now, as time goes on and technology evolves, the next generation cube base station DS-6250S is officially released here today. It's small, it's still all in one box, while placing outside the box. Improvement and innovation redefine the cube base station. Hi, Stone.
Yeah.
Would you please explain what SDR means?
Okay. SDR is short for software-defined radio. Based on SDR technology, the flexibility and expandability of base station have been improved greatly. And here today, detailed information about Hytera next generation cube base station will be shared.
4 aspects are to be shown here, namely why DMR trunking cube base station, DMR trunking cube base station introduction, key values, and application scenarios. First, let's talk about why need a cube base station. Hi, Stone.
Yeah.
Based on your experience, what pain points do you think traditional base stations have?
Sure. Through in-depth communication with customers and understanding of market demands, I concluded that traditional base stations have 2 major disadvantages. One is high costs, including CapEx and OpEx. CapEx stands for capital expenditure, which refers to the costs for purchasing, upgrading, and transporting fixed assets. OpEx stands for operating expenditure, which refers to the costs for ensuring the daily operation of the system. As we know, traditional base station can only be installed with a housing room, which will bring about corresponding fee for construction and maintenance costs of a housing room, along with deployment limitations. It is usually hard to find a right housing room to install the devices. Moreover, traditional base stations are huge with high power consumption. It will be difficult to transport device to the spot. You know what, for a project done several years ago, 4 people used a helicopter to carry that big base station to a mountain top, and it takes nearly 2 days to finish installing the base station. It wasted money and the costs were too much. One more thing to talk about is the power consumption of the traditional base station. It usually goes to over 1000 watt per base station with 4 carriers, and the electricity fee is too much. Also, lots of hardware components should be added to do base station expansion, like transceivers, power supply system, combiner, divider, and so on. It is costly.
I cannot agree anymore. With the evolution of technology, the new generation cube base station is the best answer to those problems. The cube base station is compact yet powerful.
Yeah.
Our cube base station has many advantages. Firstly, it has powerful performance with a wide coverage and high reliability. Secondly, our Cube base station utilizes advanced SDR technology to remotely configure the base station through software, making it easier to do maintenance and inspection. Meanwhile, the Cube base station has a low power consumption, only 1/3 of traditional base station, which saves electricity fee. Furthermore, the Cube base station is rugged and durable. With IP68, it can be directly outdoor deployed with no need of a housing room. Finally, the Cube base station is small and light, making it easier to install and transport.
Yes, Cube base station has a lot of advantages. Now, let's show you more detailed information. Cube base station can be widely used in various industries, like public safety, public utility, transportation, and so on. This time, we will release VHF and UHF first. Both two models have similar weight, volume, and the same IP rating. Still, there are also some differences. The first one is carrier capacity. UHF supports 2 communication passes, while there is only 1 communication pass space in the VHF, as the RF components of VHF is larger than that of UHF. One pass can carry up to 4 carriers, which means it can support 7 concurrent calls. So UHF can support up to 8 carriers, while VHF can support 4 carriers. And another difference is the TX interfaces on the bottom. We can see that UHF has 2 TX interfaces, while VHF has only 1. Other interfaces, including power, GNSS, monitor, and so on, are the same. Let's take a look at the overall appearance of the Cube base station. This is a 6-wheel diagram of it. The front is the cover, and the back is the heat sink. The 8 small holes on left and right sides are mounting holes for the back plate. Additionally, there are LED indicators on the right side that can visually display the working status of the base station, including system status, alarm status, traffic status, VSWR status, and connection status.
Amazing! The Cube base station is all in one small box, but has large capacity. You may wonder what technologies were used to transform the huge traditional base station to such a small but powerful one. I will show you the main tech used. First and foremost, we adopt LPA technology to achieve high efficiency of output and flexible frequency utilization. Multi-carrier technology breaks the limitation of base stations requiring multi-transceivers. SDR technology enables expansion while software. And thanks to the low power consumption solution, the Cube base station is powerful but eco-friendly. Next, we will introduce these 4 technologies one by one.
Yes. First, I'd like to introduce LPA technology. LPA is short for linear power amplifier. Power amplifier is a component used to amplify weak electrical signals within communication devices. However, together with the signal amplification, a certain signal distortion will also be generated. Thus, it is hard to amplify the signal with an expanded proportion due to the generated signal distortion. This is known as a nonlinear power amplifier, shorted as NLPA. Nonlinear distortion generates a large number of signals in nearby frequency bands, causing strong adjacent channel interference. Therefore, A broad carrier spacing is required to avoid mutual interference between two carriers. And the nonlinear distortion has a saturation region, which greatly affects the efficiency of the power amplifier. To address these issues, we adopt LPA technology through self-developed algorithm. The principle is to feed back the output signal to the input stage, compare it with the input signal, and adjust the gain of the amplifier through algorithm calculation. We call this algorithm DPD, which is short for digital pre-distortion and can enhance PA efficiency by 20% to 30% compared with NLPA. Another significant benefit brought by this technology is low carrier spacing requirement because of low harmonic distortion and intermodulation distortion. As we know, the carrier spacing needs more than 250 kHz for traditional base station. And now, with this technology, the carrier spacing is reduced to more than 50 kHz instead of more than 250 kHz. So the frequency utilization can be more flexible, which makes it much easier to apply for frequencies.
Yeah, then we go to the second attack, multi-carrier technology. Multi-carrier technology breaks the limitation of a traditional base station, which has multi-transceivers and uses a combiner to combine the TX port of every transceiver to one TX port. With the multi-carrier technology, the Q base station integrates all components onto a single circuit board, which we call the TRS board. From the diagram, we can see there are two paths for UHF, and each path has up to 4 carriers. So UHF can support up to 8 carriers, while VHF can support 4 carriers. All-in-one design is realized through this multi-carrier technology. It greatly reduced the size of the base station. The third one is SDR technology, which means software-defined radio. Traditional base stations are typically designed with dedicated hardware circuits for specific frequencies, modulation methods, and so on. The hardware platform of SDR has a certain degree of universality. By establishing a hardware abstraction layer and developing device drivers, precise control of various aspects of wireless hardware and deep processing of signals can be achieved through software programming, including frequency control, modulation and demodulation mode setting, and implementation of signal processing algorithm. While SDR technology, it can flexibly modify the number of carriers by software, so it is convenient for maintenance and excitation. So the DPD, multi-carrier technology, and SDR are the key technology to make the base station small and compact, as well as flexible deployment and maintenance. The last but not the least thing I want to talk is the fourth core technology, power saving. One of the key tech adopted is multi-carrier design for traditional base station. To achieve the high output power at the antenna port, each channel unit will operate with at least 50 watt output power, then go through combiner with 3 dB injector loss, and finally, the output power at the antenna port will be reduced by more than half. While for DMR trunking Q base station, with multi-carrier design and LPA tech, low output power at the TRS board can better be amplified, which reduces power consumption. What's more, low power consumption chip and heat sink design are also applied to realize power saving. The power consumption of the new chip Cube base station adopts has been reduced by 73%. Through the design of heat sinks instead of fan cooling, our Cube base station can reduce the power consumption by more than 200 watts.
Okay, just now, we have introduced 4 core technologies of Cube base station. Let me make a summary. Through LPA technology with self-developed DPD algorithm, Cube base station has high PA efficiency. Multi-carrier technology contributes to all-in-one design. Parameters can be configured by software through SDR technology. And the low power consumption solution makes Cube base station eco-friendly. All these advanced technologies are utilized to achieve higher performance.
Yeah, here we listed the main specification of a Cube base station. UHF and VHF have some different parameters, including power consumption, output power, and diversity. From the specifications, we can also tell that Cube base station is compact and lightweight, but powerful. Also, you can see the power consumption is less than 350 watts. Weight is less than 60.7 kilograms, and the volume is merely 20 liters. It's indeed light and small, yet powerful.
Yes, at the very beginning, we have mentioned about the pain points of traditional base stations. Do you remember?
High costs and inconvenient deployment.
Yes, you are right. In addition to addressing the pain points of traditional base stations, Cube base station also has other key values like high reliability, wide coverage, and so on. Let's see details. Let me explain low capex first. It includes least infrastructure, easy installation, and easy transportation. The figure shows why Cube base station can save the infrastructure costs. Cube base station can be installed outside directly without housing room, which needs construction, installation, maintenance, and rent costs, as well as the air conditioner fee. Also, when it is installed on the tower, it can save the feeder usage, since it can be directly installed on the top of the tower without the need of a long feeder. About easy installation, as we know, traditional base station is very large and heavy. And all elements such as base station control unit, channel unit, power supply unit need to be assembled on-site, which costs much time and manpower. Thanks to the all-in-one design, Cube base station doesn't need to assemble internal elements. Just require a simple and convenient installation process of several screws, so it can reduce much of the installation costs.
Yeah, thanks to its compact and lightweight advantages, Cube base station is easy to transport. Compared to the traditional 8-carrier base station, Cube base station can reduce the volume by 97% and the weight by 94%.
Absolutely. Yes. Just now, we have mentioned capex, including infrastructure, installation, and transportation fee. Besides this, Cube base station can also save OPEX, mainly for power saving. Here we calculated the year consumption compared with traditional 4-carrier and 8-carrier base stations. It is obvious from this chart that the Cube base station can greatly reduce the consumption and save electricity fee. Compared with an 8-carrier traditional base station, a cube base station can save 82% of the power consumption. Imagining with over 200 base stations deployed, a fairly huge amount will be saved in years.
Cool. That's really valuable. Next is the wide coverage. We will explain it from TS power and receiving sensitivity. As we know, the antenna RF power of a traditional base station is less than the transceiver RF port because of the in-data loss caused by combiner, duplexer, arrestor, feeder, and so on. You can see the specific in-data loss of each component, which we got from corresponding data sheets. We will take a tower-mounted scenario with the feeder length of 75 meters as an example. From the table, we can see the in-data loss is about 7 dB for traditional base station with 75 meters feeder, and about 1 dB for cube base station with 5 meters upper jumper. So even the traditional base station has a higher output at the TS port of transceiver. The power output at the antenna port is almost the same as that of cube base station, while the RF sensitivity of a cube base station is 4 dB improved compared with the traditional base station. Thus, the coverage of cube base station is larger.
Yes, you are right. Moreover, the cube base station can support diversity receiving technology to improve reception sensitivity and increase uplink coverage. This technology can be used to solve multipath effects in urban environment, where signals will interfere with each other, reduce the accuracy of the signal. Hytera cube base station can support triple diversity for UHF and dual diversity for VHF. After calculation and testing, the receiving gain can reach 3 to 4 dB, and the cell radius can improve about 20% to 30% with triple diversity. The benefit is obvious in that it can reduce seat counts within the same coverage.
Yes, while the coverage is a key concern for customers. Okay, except for long complex, OPEX, and wide coverage, cube base station supports flexible deployment. Like traditional base station, it can support cascade connection, simulcast feature. Also, it can support hybrid deployment with the traditional base station, which is very useful for base station expansion. Different from traditional base station, cube base station can support pole-mounted, vehicle-mounted, trolley-mounted to meet different scenarios and environments.
Sounds great. For a system, flexible deployment can bring a lot of convenience. And in addition, users are also very concerned about reliability.
Yes, that's exactly what I want to talk about next. Cube base station supports 1+1 redundancy to achieve high reliability. Two methods are applied, including active plus standby mode and active plus active mode. Active plus standby mode is redundancy configuration that two base stations are set with the same frequencies. Active base station works while the other base station stands by until the active one fails. Then the standby one will take over the service. For the active plus active mode, it means two base stations work at the same time with different frequencies. When one base station fails, the other base station can continue working without being affected. This redundancy mechanism for UHF and VHF is the same. But due to the difference in the number of communication paths, There are differences in the maximum number of carriers and the minimum number of antennas between UHF and VHF. The diagram above is for UHF. We can see that each box requires at least 2 antennas. Let's take a look at VHF. For VHF, we can see each box requires at least 1 antenna. And for active plus standby and active plus active mode, 2 boxes can share 2 antennas and realize due diversity while interconnecting the RX out and XD ports of 2 boxes.
Yeah, sounds great. Just now, we have mentioned low costs, wide coverage, and high reliability. What's more, what else will system customers pay attention to?
I think it is convenience.
Yes, you are right. As we know, in addition to the base station itself, an antenna feeder system, a transmission system, and a power supply system are also required to make a set of base station operate. But in some remote areas, there is no main electricity and no wired backup. In this time, our Cube base station can offer one-stop outdoor solution, including wireless backhaul, solar power system, and antenna feeder, and so on, which is convenient for purchasing.
Of course, we hope these key values can provide customers with a better experience. Stone,
Yeah.
Next, let's talk about the application scenarios, which are also of great concern to customers.
Okay. Through the detailed introduction just now, we can know that Cube base station has a wider range of application scenarios than traditional base stations, which means that Cube base stations can be used in various fields where traditional base stations are applied, including public safety, big event, and it can also be used in emergency and so on. Let's say first, public safety. In fact, Hytera's DMR trunking systems are widely used in public safety. The stability and reliability of our products have been verified by end customers. Compared with traditional base stations, Cube base stations support flexible deployment as well as wide coverage and high stability.
Yes. Cube base station is quite suitable to be installed in studio to provide temporary coverage for big event due to its wall-mounted installation. Together with DAS, it can provide seamless coverage.
Yeah. Thanks to its compact and lightweight body, Cube base station is highly suitable for emergency rescue with flexible and fast deployment in vehicles to provide temporary coverage. It can communicate with command center through satellite or 4G link as backhaul.
Okay, above is the introduction of Hytera's new DMR trunking Cube base station DS-6250S. Thank you all for joining our product launch. Your support means the world to us. So let's embrace the future with our Cube base station. If you have any questions about the next generation DMR trunking Cube base station, please contact us. Thank you.